Okay, today we're going to be looking at the ratios of perimeter and areas when we have similar figures. So the warm-up is just us to find the perimeter and area of each figure. So remember, the perimeter of a square is 4s, which would be 28 inches. And the area is s squared, which would be 49. Make sure you have square units for area. Now the perimeter for the triangle, remember there's no fancy formula, we would just add 6 plus 8 plus whatever this third side would be. To do this, you can either do the Pythagorean theorem, or this is a triple. This is a 3, 4, 5 times 2, which makes it a 6, 8, 10. Which will give me 24 centimeters. And the area of a triangle is 1/2 base height. This will be our base, and this will be our height. So our area will be 24 square centimeters.
Wait right there, Mr. Dunn.
Alright, so today we're going to be looking at the ratio of sides between similar figures, which we know is just one side over the other side, which can be written A over B, or the ratio of A to B. Now the perimeters is actually going to be exactly the same. When we reduce it, it will simplify to be the same as the similarity ratio. Now the ratio of the areas will not be the same because you'll be looking at square units. So this will actually be A squared over B squared. So if you're given the ratio of the perimeters or the similarity ratio to get to the area, you would just square the top and bottom. If you were given the ratio of the areas and you wanted to work backwards, what would we have to do? To get rid of a square, we would have to square root the top and bottom. And then sometimes we will write a cross proportion, and we will cross multiply those to get an answer. Example 1, the trapezoids below are similar. Find the ratio small to large of the perimeters and the area. So the similarity ratio, the perimeter ratio, and the area ratio. Remember, this is A over B, and A squared over B squared. So this is our smaller one, so this would be 6/9. We do want to reduce that, which would be 2/3. So the ratio of perimeters would also be 2/3. The ratio of the areas would be 2 squared over 3 squared, which is 4/9. So those are the two answers they asked us to find. Example 2, two similar polygons have corresponding sides in the ratio of 5:7. The perimeters would also be 5:7. The areas would be 5 squared to 7 squared, which is 25/49. So remember, if they ask you for a ratio, it's just a fraction, and you can either write it as a fraction or in ratio format. Now all the other ones are going to be a little bit more challenging. Notice they've given us two similar pentagons. The area of the smaller pentagon is 27.5 square centimeters. Find the area of the larger pentagon. Now normally we would just write a proportion. 4 over 10 equals 27.5 over A. But the problem with that is we have area, which are square units. So the first thing you have to do is you have to find the area ratio. So the similarity ratio is 4 to 10, or 2 to 5 if we reduce it. The area ratio, remember, we have to square those. So that will get me 4/25. Now we can use the area ratio to write a proportion. So we will have 4/25, which is our area. We can set that equal to the areas of the shape. The area of the smaller one will be 27.5, so that's going to go in the top because the smaller ones were in the top. And then I'll just put a as a variable in the denominator. And then we can solve this by finding the cross product. So the area of the larger shape is 171.875 square centimeters. The next one tells us the similarity ratio of two similar parallelograms is 3 to 4. The area of the larger parallelogram is 96. So let's go ahead and draw two parallelograms. The similarity ratio is 3 to 4. The area of the larger parallelogram is 96. Find the area of the smaller. So again, the biggest mistake I'll see is students do 3/4 equals A/96. You cannot set similarity equal to area. It has to be area to area. So the similarity ratio is 3/4. The area ratio is 3 squared over 4 squared, which is 9/16. Then we can use that to write a proportion. It has to be area equals area. Now this time our unknown area is the smaller one. So that will go in the numerator. 96 will go in the denominator. And we go ahead and we cross multiply. Should get 54 square inches. In the back, similarity ratio of the dimensions of two similar pieces of window glass is 3 to 5. The smaller piece costs $2.50. Now $2.50 is representing the whole thing, which would mean the area of that piece. What should the cost of the larger piece be? So again, we would have our similarity ratio, which is 3/5. We would have to find out what our area ratio is by squaring top and bottom. Then we can write our proportion. So 9/25 equals 250 all over x. And we cross multiply. All right, the last four give us different information and ask us to work backwards. So they want us to actually find out the similarity ratio and the ratio of the perimeters if we're given the ratio of the areas. So if you remember, similarity, perimeter, and area. We have A over B, A over B, A squared over B squared. So in this instance, we're given the area ratio, which would be 50 over 98. Now to get backwards, we need to square root. The problem is I don't know what the square root of 50 is. So always try to reduce if possible. So if I take and divide each of these by 2, I'm going to get that the area ratio is actually 25/49. Then I don't have to work with reducing radicals. Now I can square root these, and I will get that my similarity ratio is 5/7, and my perimeter ratio is 5/7. Same thing here. We're given the area Now something you actually can do here, you can divide those out. I would leave this as a fraction though. This is 25/1. So to get back to the two ratios, we have to square root. Just square root the top and the bottom, which will get me 5/1 and 5/1. This one we have two regular circles. Areas are 4 pi and 400 pi. Now the pi's themselves can actually just divide out. So again, we're going to square root. You can square root as is if you'd like, or you can reduce. 4/400 is really 1/100. So whenever I square root those, I'm going to get 1/10 and 1/10. And the last one, we have the areas are 32/72. Now again, if I go straight to square rooting, I don't know what the square root of 32 is. So try to reduce first. So 32 is divisible by 2, or it could be divisible by 4, or it could be divisible by 8. So that will get me 4/9. Now I would square root those, and I will get 2/3 and 2/3. Closure, we have two triangles. Similar ratio of 5:3. The perimeter of the smaller triangle is 36, and the area is 18. Find the perimeter and the area of the larger triangle. Go ahead and pause the video and try this one on your own. To find the perimeter, we should be doing our perimeter ratio, which would be A/B, 5/3, equals P/46. Cross multiply. Should get P equals 60. And for the area, be careful, we should not be doing 5/3. You have to find the area ratio, which would be 5 squared over 3 squared. So that's 25/9 equals A/18. And we will cross multiply here. and we should get 50 square centimeters. All right, your homework is the 10.4 worksheet.